Hey guys, welcome to another lecture in Precalculus. Today we're going to talk all about slope. So slope is one of the most important topics you will come across, and it's fundamental to what we'll be learning in calculus and later courses to come. So what is slope? Slope is pretty much the rate of change in how steep the line is. So the slope of a line is simply how steep a line is. So let's take a look at what that means. So if we pick 2 points on this line, so this is the y equals x line, let's say 2, 2, say that's 2, 2, 2, 2, and let's take 5, 5. Let me draw this 5, 5 out. So something like 5, 5. That's pretty wobbly. I know it's not even, but it's y equals x. So we're taking the coordinates 2, 2, and 5, 5. So the question is, how steep is this line between those 2 points? How steep is this line between those 2 points? So the slope, the slope is simply the change in y over the change in the x. So what does that mean? This means that, I'm going to move over to the left-hand side here. This means that if we're starting at 2, 2, we know this is the x, this is the y, and we are moving all the way up to 5, 5, and this is the x, this is the y. We have to look at the change in x. So how much does this change? So it goes from 2 to 5. So we can take that as in backwards. So we can go as 5 minus 2 over 5 minus 2, which is simply 1. So the slope of this line is 1. The slope of this line is equal to 1 because of the line, and it's y is equal to x. So the rate of change is simply 1 every time, right? You're pretty much skipping up by 1. You're scaling up by 1. And later on, when we talk about the formulas of lines and how lines come to be, you'll actually see that slope is 1 in this sense right here in this equation, y is equal to 1. So slope, another thing to know about slope is usually denoted by m. It can be denoted by anything, but generally we see that slope is denoted by m. I'm not sure why, but that just happens to be the case. So what's the point of knowing slope? So why would we even want to know slope? Why does it matter? So slope is pretty much how fast something is changing, how fast the y variable is changing in response to the x variable. So let's do that again. So let's say there was a line here. So what do I mean by how fast something is changing against another? So for in physics, we'll actually use this as the x and we'll use this as time. So this is a position over time graph, a position versus time graph. Simply, we're just using x and y, and the axis, all we're doing is just changing the names. So what does this represent? This means at time 1, this person was x equals 1, which we can represent in some sort of, let's say there's a line graph, and there's some 0, so 1 meter, 2 meter, etc. So x is in meters, let's say. So this means at time 1, this person was actually 1 meter ahead, and at time 2, 2 meters ahead, etc., etc. Even though in physics we would only have this because there's no such thing as negative time here. So let's say this is a positive only, so we can ignore these and we just look at this. So what does slope mean in this sense? The slope is how much distance are you covering in an X amount of time. So if we were to look at our points that we took before, 2, 2, and 5, 5. So 2, 2, and 5, 5. I know that's off a little bit, but that's okay. 2, 2, and 5, 5. And let's just assume this is also y is equal to x, or in this case, an x is equal to t line. And pretty much what you're saying is that since we know the slope is 1, we're saying that the person moves at a rate of 1. So what does that mean? Does that sound familiar? So moving at a rate of 1 means speed. That means their speed, their average speed or average velocity, if you have direction, so in this case you do, the average speed is equal to 1. The average speed is simply the rate of change of delta x over delta t. So what is delta? So delta simply means the change in, as we did before. So we take the the higher number x and subtract it by the second lower coordinate. And one thing to note is if we're going from left to right and the direction of this is pointed upwards, so you see how this is pointing up, this is pointing up, this is pointing up, this means that we have a positive slope, right? So our average speed is positive. Now imagine if you had something like, let me add another line here. Imagine you had something like this. If you had something like this, you see that we're actually going down now, and this is simply a negative slope, which means in terms of physics, you're actually slowing down, right? Over time, you're slowing down. And if you had something that went straight across, let's say we had just a straight line across, this means there is no slope. That means that there is no rate of change. The change is constant. It means that we're going to stay, regardless of the time, we're staying at the exact same spot. Some more just cool things you might come across in physics is the change in x over change in t is equal to velocity, or the speed. And then if you were to take the change of velocity, which is v, over change in time, you actually get acceleration. And you can actually keep going and find further and further properties. And these are fundamental laws of physics. It's the rate of change of something over time. And you'll see this over and over again in math. So let's generalize this in a simple formula so that we'll remember how to do this from now on. So let's do y. You have some coordinate 10, 12, and you have some coordinate a and some coordinate b of 17, 17, let's say 28. So I want you to find the slope, find the slope, find the slope between A and, between A and B. I'm not sure I missed the A. So let's give this a try. So the formula for slope is equal to y2 minus y1 over x2 over x1. And sometimes you'll see this written as the rise over the run because you're talking about how far how far along does it go up? So how far does it go up? So how far does it go up? And then how far does it come to the right? How the rise over the run. So let's calculate this now. So y2 in this case is you're taking this is y2, this is sorry x2, and this is y1 and x1. So y2 minus y1 is 28 minus 12 over 17 minus 10, and 28 minus 12 is 16 over 7, and that is your rate of change. And you can simplify this, or usually you just leave it in fractions, and that's good enough. You don't have to find the decimal version of it. So yeah, so if this was for example, if this was two different positions over time, the speed is 16 over 7. So hopefully you guys learned something new about slope. We're going to get a lot deeper into what slope means and a lot of examples. And as usual, I will leave problems in the description below. And if you have any questions, feel free to leave them in the comments. And hopefully these videos are getting slightly better and I'm not going off topic too much. Yeah, and make sure you subscribe, make sure you like, and I'll catch you guys in the next one.